Okay, hi Stephanie. I am Pablo Slavkin from Argentina. I am doing this video to show you my code of the exercise. You asked me a couple of weeks ago. I am working on this at night, and so I have to doing some stuff in the middle, but I guess it's finished. I will begin with the main organization, the tree of the code. So I have to show you these three directories is for .wav audio files, audio sample files. This dir is for save the application for Windows and Linux. This lame.8 is the local copy of the lame library header. This is my code. This is mine.c++. I decided to code in only one file for this. I decided that for simplicity, and I focus on short code, not a big project. I focus on short code and show you my style. This is the make file. The object directory is for saving some debugging information. Use the dump tools. A little readme, and there I save the static libraries for Windows and Linux also. So there is my stuff. There is the libraries, the archive libraries for static compilation. This is the debug that I told you. The executable files and the DLL, I copy that for Windows. There is the audio sample files, and so that's all. Let's begin with main. There I have some headers, include the stuff that I use. In the beginning, I show you the main. I detect the arguments count. If it's less than 2, I show you a message if you choose the debug flag. If not, silently closed. I choose a strategy using this is I guess is the my main decision to choose how to distribute the task. In the beginning, I use a for to test the task and a write of task pointer to test when the task is over, and then I take another task and take another core and attach a task to a core. But then I decided to do it in a simple way, because having an array of task pointer, I have to I have nothing to do with the task pointer, only to run the task, and when the task is over, finish the task. So I don't use the join style, so I detach the task after I attach the task to a core. So in the main, I take the first parameter, define a string vector. A string vector is a string vector. It's a vector of string that I define it here in a type def, so dynamically allocated. I test the dash, because if you don't put the dash in the end, it's not comfortable with the directory's functions that we will see in a little. Then I use my strategy using semaphore. I use shared semaphores that I define here. I use the task sem. So using that shared memory, I have to count the cores. I dynamically initialize the semaphores with the core quantities that I define the cores I define here. So this is the dynamically calculation of the cores quantity of the CPU, and I use that here. So I initialize the task sem with that quantities. Is not a binary sem, is a counting sem. So then I find the WAV-files in the directory that I have added the dash. So here I fill the files, the string vector files, with all the .wav files, and after that I simply chance to convert WAV to MP3s with the directory name and the file vector. So go inside the first function, find WAV files. It's simple. Use the open dir function to go to the dir, and then I do a while with all the files until I have reached a null, and I test if it is more than 4 chars, like 1.wav. I don't expect less than that, and after that I find the last dot. So I take the substring from the back, and after that I convert the whole extension to a lowercase, because it's simpler to test the sound. Okay, WAV, and you might choose, okay, wait a minute, okay, WAV, and you have, I don't know, WAV. So all the combination, it's possible to detect. And when I found the WAV extension, I push back in the file that I passed in, like not a copy, like a pointer. So I fill the file string vector with all the .wav files here. Doing that, after that I call this function. That it's this is the main piece of code. You see that it is very short. So I simply do a for all the WAV files. Take a sem here. If a sem is available, I simply go to the next line and begin a task with this function and this parameter. Note that I put the parameter dir plus the file, so I combine the directory name with the file name. So I pass that string concatenated string to that function, and after that, this is the main stuff. I simply detach. I simply do a thread detach, so the task run on his way, but the task can reach the shared memory of the main code. So in the end of the convert one file, I simply free the SEM. So after the SEM gets free, I could continue with this for. And after all the MP3 is on his touch, the code stop here and wait, but not consume CPU power because it's a SEM. So it stop and waits the syscall to send a message and continue to the other task. When all the cores are filled with tasks and there is no other files, all the cores are working with his own task. So I put this snippet for waiting that pending is less than score. So I take the same value when same value got the total core. So it's the indication that all the cores are free, his own stacks, his own stacks. So all the files are done. But take note that I use sleep function here because if not, this for has no stop. He's run doing nothing, waiting this function get the course number. So if I don't put this, one core got stuck, got overloaded with doing nothing. Okay, that is the main piece of code. I comment that if I choose join here, I can use only one thread, and if I choose array of task pointer, I have to take an account with a for, testing a flag with in each of the task. So this code gets much longer. Okay, but it's another possibility. I tried both styles, and I prefer that. In that, with this requirement you pass me, I prefer that. When you add another requirement, I think that I have to move to the other way. I have to do take this thread is not only one pointer. I have to make a dynamically initialization array of task pointer and do some stuff with that. But you don't ask me to do that, so I did that way. And encoder function. This is the function that runs in a task. I copy a little snippet from the documentation of Lamin library. So I open both files, the files .wav-files, and I create a mp3 file name with that substring function, adding mp3 extension here. After that, I opened both files and I did a little error check if I can't open the files. It's not the best way to manage fopen, and so I have to do a lot of stuff to be very strong about the error, but I prefer to maintain the code size short to show to this exercise, but for strong way to manage fopen and fwrite, I have to do a lot of stuff here. When I read a file, I have to check that function, and also that I have to fill all the code with error check. I prefer to keep this way, that is cleaner, but I have to tell you that for production code I have to do a lot of stuff here in that part. But I test the minimal way. I use a flag here and test the null pointer of the files to not write in nothing. Encode the WAV files, close the files, close the lame library initialization, and if you choose the bug flag with 1, I print some little information about what is being doing. But if you don't use the bug code, the command line application finish without any charge output in the screen. So this is the information to the kernel that free the SEM, the shared memory semaphore. So this line is the line that use here. Okay, here. When all the cores are busy, the code stop here and is waiting this line. So get doing that, I have to show you the makefile. Makefile, I detect the operation system with this variable. In Linux it isn't defined, but in Windows do. So I detect that and choose that piece of code or that. But I added this flag also, statically, to choose and compare the both compilation styles, statically and dynamically compilation. So I use in Windows, I have to tell you that I use Cygwin to compile for Windows. I have not a Windows machine at home, but I start a VirtualBox Windows 7 version, and I prepare the Cygwin environment to compile my application. So if I use the static flag here, the compiler try to use the static version of all the libraries I use, liblame and repthread, GCC, std, C++, etc. And if not, I use the dynamically DLL version. In Linux, I use the linker flag using the WL. So I choose static here, then followed by libmp3, and then I revert to dynamic. So in this line, I compile the liblame statically, but all others library like GCC and std++ in the dynamically way. So the application file is more shorter than this way, because in this way all the libc code is were inside the application, and in the dynamically way for Linux is simpler. I use the .so here, and so in that way I compile the statically. I do a make with statically. I am using the .b to show some message. So this generates okay, I made a mistake here. Okay, I did a fold in my editor, so I go to okay, let's show you okay, no, something is function definition. Okay, I broke something here. Okay, here. Let's see. I did some mistake here. Yes, I until I begin with the video, I do some folding, but I did it in bad way. Let's see, that's no, it's not good because I have to choose that. Okay, I guess it will work. Make. Okay, this is the statically compile. I will start again the pointer. So you see that I choose here in that line static, liblame, dynamic. So std C++ is dynamic, but this is static. LP3 is dynamic, this is static. So and if I choose dynamic, so this lame is, where is lame? Here. There is no statically computed. So if I go to exe and show the versions, this is the Linux dynamic 54 kilobytes, and this is the static. And if I I could use LDD to show the WAV Linux files, and there you see the okay, there it is. This is liblame, dynamically compiled to user lib blah 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 liblame. So this is the static version when liblame is not in the list, because it is included in the code. And if I go to ops and look inside the object static Linux, if I look at the lame init, for example, lame init has all the code here, but if I use dynamic dynamic Linux and go to liblame, this is all the stuff because it's linked with PLT segment. So the this application need the dynamic library. Okay, saying that, I go to my Windows virtual machine. You see, I have here is the processor. Okay, this is my Sigwin and the command line CLS. Okay, this is the same shared directory, so it's the same stuff. So if I make the make in this way, I am using the I don't remember the dynamic way. So This is the dynamic win exe here. That's weight, that's a little kilobytes, but if I change, if I change with a 1 and choose make, okay, this will spend a little effort, more effort, and the ops dump is bigger also, and this is the static compiled version, and it takes a little time. Okay, it's done. And if I list, there you have the statically win. Okay, here 8 megas. So if I go inside the object file, like in Linux, and go to the object, if I look at inside of statically window, and it's big file, but if I go to laminate, for example, laminate is dynamically compiled because here I wrote a to-do line. I can't figure out where is the liblame.a for window, but statically compiled. The liblame.a that I had, the only one that I found is dynamically compiled, linked with the DLL. So no matter if I choose static or dynamic, liblame is always compiled against the DLL. The only thing that this flag changes is the lib GCC and stdc++ lib, not a liblame. So the 8 megas file size is because the lib GCC, not liblame. So it's not business using that static flag here. The question is that if I use the application outside SIGWin, and I have to use, for example, the static win, and use this one is a couple of WAV-files. It works, but if I use the dynamic windows with disk, disk 1, it doesn't work because I have to use the 6 SSL. So the only thing that this flag changes is that I can run the application outside SIGWin. In SIGWin environment, I can do whatever. WAV statically disk 0, static work, and dynamic, for example, dynamic also works. In Linux, I have to choose that. WAV statically Linux disk 0, it works, and if I choose dynamic Linux, it also works. But at least I have to show you. Okay, the one thing that I have to test is that disk 0 support this WAV. This is the WAV files and the MP3. So I have to. Okay. The encoder works also. and at least at final I will do that. This one is bigger, so after that with 4 cores, because it's the native installation of Linux, and in Windows, if you see, it is working with 2 cores because my VirtualBox is defined with 2 cores only. I want to show you this with the cores like that. Okay, like that. I am using here the 4 cores running at 100%. And if I did the same in Windows, I will choose maybe these 2. Okay, I will do it in the command line for now. It's the same, but okay, this is not the statically. Okay, 2 cores, and I will show the CPU's historic, and you can see the 100% in both cores. So okay, this is done. Okay, this is working, and here also, and this is finished. Okay, this is done. After that, I have to tell you that I did a GitHub project, and I will use a Git. I will comment something about folding. I will write corrijo un detalle de los fold que no dejaba compilar, y I will push it to the GitHub. Okay. Okay, it is uploading. I will show you the GitHub also. Okay, I will wait that. After that, I will send you an email with the link of the GitHub project, and also a link to a YouTube project, video of this video. So I guess this is all that I did. I guess it took me maybe 20 hours of coding, maybe 20, maybe 30, no more like that, not less that. I guess not less that 20. I spent a couple of hours dealing with Windows stuff, because I used to use Linux, not Windows, so I spent a couple of hours with that. But the principal code maybe took 10 hours, yes. The main piece of code, it took me 10 hours to test, and looking and the statically compiled and dynamically all that stuff, it took me maybe 8 hours also, because I have to deal with the live-lame.a that was not statically compiled, so it took me a couple of hours dealing with that. And after that, I could investigate the object file using object dump tool to see what is going on. So I wrote the to-do line. Okay, that was it will take a couple of time because I add a .wav file, .wav sample file, so because of that it is getting slow, but okay, send to nothing. I will show you the github.com, and this is my project. Okay, there, this is the project. I use the readme. Okay, I will wait 22. My internet is it's a little saturated because I am uploading some files also. Okay, okay, but it's not important. You will see the new version when you link my email, but it's not important to wait that. Okay, that's all, Stephanie. We will keep in touch. I will wait your answer, your feedback. I am very interested in working with you and show you the things that I could do and collaborate with your project. So I be here. So nothing. Best regards and bye bye.